What if in 2026, humans didn't just visit the moon, but they lived there? Since Neil Armstrong first set foot on the moon in 1969, we've imagined the possibility of returning. But this time, it wouldn't just be a visit. We're talking about staying for good, and it's not as far-fetched as you might think. With NASA's Artemis program aiming to return astronauts to the moon by 2025, and private companies like SpaceX accelerating space travel technology, living on the moon in 2026 is actually within our reach. So where exactly would we start? The moon's surface is hostile, barren, and bombarded by radiation. We can't just set up a tent and call it a day, but there's one place that's caught the attention of scientists: the moon's south pole. More specifically, the Shackleton crater. Why there? Well, it's one of the few spots on the moon that gets near continuous sunlight, about 80% of the time, which is crucial for solar power. Plus, there's evidence of water ice hidden in the permanently shadowed regions of the craters. This ice could be our key to survival. Water, after all, is life. But how would we extract it? Scientists are already working on ways to mine lunar ice and convert it into drinkable water and breathable oxygen. The plan is to use lunar regolith, the moon's soil mixed with ice, and process it through a system called ISRU, or in situ resource utilization. Sounds like a fancy term, right? It basically means using the moon's own materials to create water and oxygen, which would save us from constantly shipping supplies from Earth. But where would we live? Enter 3D printing. Companies like Icon are developing methods to use lunar regolith to 3D print buildings on the moon. These structures could protect us from harsh solar radiation and extreme temperatures. So imagine a moon base entirely built by machines using nothing but moon dust. Okay, so we've built our base and have water and oxygen. But what about food? It's not like there's a McDonald's on the moon yet. Growing food on the moon is one of the biggest challenges we'd face. Right now, scientists are experimenting with growing plants in simulated lunar soil here on Earth. The goal: to create a sustainable agricultural system on the moon using hydroponics growing plants, without soil land, possibly even vertical farming. But survival isn't just about what we eat or drink. There's also the issue of gravity. The moon's gravity is only about 1/6 of Earth's. Sounds fun at first. This low gravity would cause our muscles and bones to weaken. Astronauts on the International Space Station already deal with muscle and bone loss, and they're only there for months at a time. Long-term moon settlers would need to combat this with constant exercise and possibly even live in rotating habitats that simulate Earth's gravity. And don't forget about radiation. The Earth's magnetic field protects us from harmful space radiation, but the moon has no such shield. That's why those 3D printed structures we mentioned earlier are so important. They'd be designed to block as much radiation as possible. And some ideas even suggest building part of the moon
base underground within the moon's lava tubes, which could offer natural protection.
We power this entire operation. Solar power seems like the obvious answer, especially in places like the moon's south pole where sunlight is abundant. NASA is already developing lightweight, flexible solar panels designed for lunar conditions. But what about the 14 days of darkness that cover most of the moon during its long night? That's where nuclear power comes into play. NASA's Kilopower project is developing small, portable nuclear reactors that could provide constant power even during those long lunar nights. This technology would ensure that we never lose electricity for life support systems, heating, or scientific research. You might be asking, why go through all this trouble? What's the point of living on the moon? Well, for one, the moon is a perfect stepping stone for exploring deeper into space like Mars. Before we commit to sending humans to Mars, a much riskier journey, we can use the moon as a testing ground to figure out how to live on another world. But there's more. The moon could become a treasure trove of resources. One of the most exciting prospects is helium-3, a rare isotope that could potentially fuel fusion reactors on Earth. If we can perfect nuclear fusion, we're talking about nearly limitless clean energy. Some scientists believe that mining helium-3 on the moon could even become a major industry in the future. And then there's the science. The far side of the moon, shielded from Earth's radio waves, is an ideal location to set up telescopes that could give us unprecedented views of the universe. The moon could become humanity's greatest laboratory. But it's not all about technology. There's a human side to living on the moon. What would life really be like for the first lunar settlers? Isolation, for one, would be a huge challenge. It's not like you can just hop on a plane and fly back to Earth if you get homesick. Astronauts on the International Space Station are isolated, but they still have near-constant communication with Earth. On the moon, communication with Earth would have a delay, and living so far from friends and family could take a psychological toll. How do we deal with that? NASA and other space agencies are already studying the effects of isolation on the human mind. Astronauts on long missions go through rigorous psychological training, but long-term isolation on the moon would push the boundaries of what we've ever experienced. And then there's the question of community. What kind of society would emerge on the moon? Would it mirror Earth's social hierarchies, or would a new kind of social structure form based on cooperation and shared survival? It's fascinating to think about how living in such an extreme environment could shape human behavior. So could humanity really start living on the moon in 2026? The short answer is yes, but with massive challenges ahead. The technology is being developed. The plans are being laid out. And with organizations like NASA, SpaceX, and international partners working together, the moon is within reach. But it won't be easy. Building a permanent presence on the moon will test our resilience, innovation, and our ability to work together on a planetary scale. If we succeed, though, it could mark the beginning of a new era for humanity, one where we're not just Earthlings, but citizens of the universe. So the real question isn't whether we can live on the moon, it's whether we will. And if we do, the possibilities for what comes next are limitless.